In this third lab, we will talk about the magnetic field of a power magnets. The objective of our lab is to measure the distance dependence of the magnetic field and to compare the value with the predicted field or the distance from the equations we use from Biot-Savart law. One fact we'll consider that the closer the magnet, the stronger the magnetic field, and our main result is that the distance dependence with 1 over r cubed and our mu value. Physics principle in this lab is that we use the magnetic field of Atlanta, and the second equation talks about the bar magnet and to find the value of n, and finally we use the general formula for calculating the magnetic field of a dipole. The first thing is that we put a sensor in which the magnetic field in the x-axis to the earth is to be 0, and we will measure the distance in which the x component of the magnetic field of the paramagnet is first equal to 20, and then change that number on different tries to find different distances and repeat that 3 times to get the average. So to calculate the value of k, we will use the previous equation, and we'll find that the slope of the graph is n, so the n value is this number, and we can now find the length of k and then find finally the value of k. We will now find the mu of the magnetic field, which is our object of this lab, and since we found k from the previous graph, we use this equation and we use 2 because it's parallel, and after calculation we found the value of mu. So to begin with our code, we first created the magnet, and then we put our mu that we found from the experiment, and we define a function to find the magnetic field over distance, and we put our scale in distance from the experiment. This is the part that we created the arrows, in which we will discuss that later. We first put the 2 arrows of the axes, and then we would put them as perpendicular. And this is the final part in which we visualize the magnetic field over a 45-degree of axis, and we put the d perpendicular in which we found it from the experiment, and we got the observation location, and finally we got the magnetic field over a 45-degree. This is our model, and this is the picture of it, and you can find some variables or some vectors down there to describe the things that happened in this model. This is the part that we calculate or evaluate the 45-degree angle experimentally, in which we found the magnetic field of the earth and at 45-degree angle, and after subtracting the value we got this value, and finally we got the final answer with the code from the previous model. So what if we hadn't oriented our experiment to compensate for magnetic north and had instead laid our meter stick at some intermediate aspect or angle with respect to the earth magnetic field? How would our results have changed? So my answer for this question is that the approximation that we made about k and mu won't be valid, since our approximation won't be parallel or perpendicular. And the second question is that if we were to stick 2 identical magnets together into end and run the experiment again, what would happen? First, that the magnetic field of the magnets should be stronger and then larger. So both distance and the computed values will also differ. So in conclusion, we found the value of mu, which is of the magnetic field, and we found the value of n, which is the slope of the graph, and we found that the distance dependence with 1 over r cubed, and the calculated values from a real experiment found to be with the paramagnet is similar to the values of the model and the Biot-Savart law.